Hello, everyone. So you've seen a lot of features from NX, and this talk is about extending NX. So we're going to get a little bit deeper into NX and see how we can extend it and how we would do it. But first, as they said, I'm Benjamin Cabane. I'm an architect at Narwhal, and I'm in the NX core team.
And I'm Jack Su. I'm also an architect at Narwhal and a core NX team member.
OK, so let's start with something we can all agree on. We love JavaScript. This is our go-to language. We mostly work with it like every day, and we are pretty familiar with it. It's easy to contribute to a code base in JavaScript, and JavaScript has a huge community. We develop front-end, back-end application, and also on other platforms like desktop and mobile. JavaScript is a fast and a good solution for creating tools, scripts, and command lines. So this is why NX is pretty much written in TypeScript. JavaScript ecosystem is developing rapidly, but there is still work to do on the developer experience. Usually, when we are working on a project, it goes a bit like this. We have our directory or tree structure with all those directories. We have all those files. This is pretty boring, and we need to do active work. We basically make assumptions, and we need to pack all the code and all the folders to read the names, read the names of the files, make assumptions about what the code is really doing, and then we need to open those files and check the code and validate or not all our assumptions. So basically, we need to build a mental map. And that mental map is always changing, so basically it's always false with all your code changes. Then we have NX, which adds a new layer to it. It starts by analyzing and processing all this code inside the workspace. It reads all these lines, look at the imports into those files, look at the folders, and start making connection with them. So we now have a high-resolution graph that NX is creating for us with what's going on inside the code, and we can look at that graph with the NX graph command. NX does that mental map basically for us, and it's always up to date because it always recreates and look at all those imports behind the scenes. So what we have now is basically knowledge about how the code is consumed and used, how it is tied together, and what architecture do we have, because the directory tree structure may not be the same architecture as the application itself. But why is the graph so important? Well, this is actually pretty simple to answer. The graph is used for everything. Detecting dependency between every bit of code, orchestrating tasks, knowing what is affected by our code change, managing the caching system. So we have that representation of our workspace, and basically we can see that we have here two application, two projects. So it usually goes like this. We have one application, and the other part is usually an API or another project. And we can see that we have a library that is shared upon those two projects. And usually, those can be the models that are shared between the application and the API. So we are really happy about that because this is a good developer experience. We have an architecture overview. We have the interaction between those libraries and packages. And we have explicit code reviews. The detailed graph, the representation that NX does, it does it because it understands the whole code inside the workspace. And this is because everything is done with the same language. Now, the problem is we usually have our application, main application in JavaScript, and we have another project that is written in a different language that NX doesn't know to handle natively. And this is basically our API here. So we want to know what's inside this gray box, how it is structured. Maybe there are multiple packages that we are using, and we want to see all those connections. And we want to see if there if there is any interaction between those two projects, if there is like a shared package between the application and the API, like we just saw in the previous slides. So this developer experience is not really great, so we are pretty sad about it. Because what we want to know is maybe this API is written in Go and has a few packages that this API is using. Maybe this is written in PHP, maybe this is written in Rust, or Kotlin, or Java, or any kind of language that you want to use. So basically what we want is what's inside the gray box, how it is structured, and what are the interactions possible, or if there are already interaction between those two projects. So we can do that by extending NX, and we extend NX via plugins. And to extend NX, we need first to understand how NX is structured. So there is basically two big blocks in a simple way. The first one is the core that handles the task scheduling, the task dependencies, the affected command, the distributed task execution, the graph visualization, and the tooling integration for the console and the NX console. Then we have the plugins, and we have different categories for the plugins. We have the functionals that are helping NX to understand JavaScript and how to build it with Webpack, ESBuild, and we have other kind of plugins that are more framework related for Remix, Next, Angular, or Express. We also have tool-specific plugins for example, the Storybook, Cypress, and also for different kind of platform like React Native. So what we want to do is add support for any language by extending NX. We also can do the support for any tools by extending NX. But basically what we really want to do is add support for any behavior by extending NX. So we're going to see 3 extension points or 3 domains where we can extend NX. The first one is the graph. The second one will be the executors, and then the generators. So let's start with the graph. So here, this is the project graph application, and we are taking an example of the nx.dev project, which is the project for the documentation of NX. And you can see that there is a lot of dependency for that project. There is a lot of edges and nodes. And what is a node? A node is following this kind of interface. So you have 3 properties. The first one is the source, which is the project that is focused on. The second one is the target. The target is basically the dependency of the project. And then you have 3 types. The first one is the implicit, static, and dynamic. And NX will look at all those types. The first one for implicit, this is manually. So you're going to go to the project.json, and you're going to add manually the dependency for the docs here, which is the content for the website. And NX natively understands JavaScript. So with the AST parsing of your files, NX knows what is a static import and knows what is a dynamic import. So this is really useful. And with that, you can see that NX understands your workspace and is able to show you that graph. But behind the scene, it just looks like a multiple list of projects with this type of interface that we just saw. So the first one is about the documentation content. Then we have like a data access library, which is static. And I'm going to just focus here for the React dependency, because NX, even if it doesn't show you that on the graph itself, it knows that your project depends on a third-party dependency. So here it's React. Then we have the executor that are focused on streamlining tools and commands. At their core, they are a function that performs actions on your code. So think about building, testing, linting, etc., serving. And they are kind of a superset of NPM scripts. but they're focused on the behavior that you want to add to your workspace. So basically, they will abstract. The person that is on your team that knows the tool will create an executor and abstract the whole complexity of that tool, giving you a set of options to configure the behavior of that tool. And you will be able to use all the NX feature that, like the caching and the distributed task execution. And it will also be easily shareable between all your projects just by reusing the executor, changing the options, and creating a new target for another project, for example. Which is really different from the NPM script, which are really custom, and you always need to basically be an expert in a tool to change and craft that command for all the projects that need that specific tool. So it's really a ad hoc situation, a ad hoc solution, and we're pretty sad about it because that just doesn't scale at all. Then we have the generators. The generators, I think you all know what they are. They are CRUD operation and configuration. They are a function that automates tasks on your code. So scaffolding, when you use NX create workspace, you're using a generator. When you do the migration, you're using a generator. When you install Cypress, you're using a generator. So yeah, I think that's everyone understands that. So that was the theory about how we can extend NX and where we can extend NX. Now we're going to see a real practical example by creating a Go plugin.
All right, thanks, Ben. So as Ben pointed out, oops, almost fell off. We're going to go through an example, extending NX to understand Go, the language. And we're going to see later how you can apply this to other languages. But for now, what you want to do first is install a package called NX plugin. And what this will do is it provides some generator, some utility to help you develop and manage your plugin. So once you have that installed, you can go ahead and call NXG and generate our first plugin. So we're going to call it Golang and pass it a minimal flag to avoid some boilerplate. So we're going to go through this in 3 phases. The first one, we're going to generate an app and a lib generator for a Go application. And then we're going to build this one executor to build our application. Then lastly, and the most important part, is we're going to teach NX how to read the Go source to understand the dependencies between the different projects. So first, recap on generators. You probably heard about it all the time now, but they're operations on the virtual file system. So what that gives you is the ability to do dry runs before you commit to the actual file changes. And the other thing you can do is you can compose existing generators into a new one. So if you have something that maybe is provided by NX itself, you can go ahead and call that. Here, we're going to generate 2 generators. So we call NXG, and I'm going to call one app, and the other one's going to be called lib. And we're going to pass it the project Golang. So now it's going to be part of our plugin. So here's an example, a very, very basic example of what the application generator might look like. And you're going to notice we're going to import a bunch of functions provided by the dev kit. So the first one, and this is probably going to be very common if you're going to be creating applications, is we're going to add a new project configuration to NX Workspace. And then there's also another function called generate files. And this is a function that's going to copy some files over from a directory. And because it's templated, you can do some variable substitution if needed. And lastly, we're going to format the file. So this could be some JSON files, maybe some YAML files that will be formatted. So now that we have our generators implemented, we will generate the app called API. And there's going to be a lib called auth for authentication. And you'll notice it's just used as normal. So we use it just as a normal NX plugin. And you can do dry run for free out of the box. So that's generator. Now, executor, they're basically performing actions on your code. So you can think about building, but also linting and testing. And just like their generator counterpart, they're also composable. So if you have existing executors, you can call them within your executor and build up new ones like that. So here we're going to create a new executor called build within our Golang plugin. So just like a generator, we have a generator from NX plugin to do this for us. And now that we have that, here's a very, very basic example of how we can build the Go program. And this is not really production ready, so I wouldn't copy this and go ahead and start building stuff with it. But what we're going to do here is called Go build, and we'll pass it two options. So the first one is the dist, or the output path, where the binary will go. And the second option is the main entry point. So this will be your .go file for your program. So now that we have that, we can use it. So the way that you want to do it is open up your project JSON, and we're going to configure a new target called build to use this executor. Now, you probably want to put this in your generator, so you don't have to do this manually all the time. But your file will look something like this. And if I run it, you'll see NX build API, and it's going to run, generate the dist, and I can run it. Here, all it does is print out hello API, which is not all that useful, but you can imagine it starts up a server somewhere. So let's recap. So far, we have our two generators, one for API, one for auth. And you can imagine at this point, I have imported my authentication library into my app. So those are the generators. And then we also have our executor to build the Go program. Now, the more complicated part will be, now that we have this, so we have our two projects, what happens when you run NX Graph? And this is what you'll see, which is cool because NX doesn't care about what language you use, so knows that these two projects are in the workspace. But the caveat here is that NX only analyzes a code if your projects are in JavaScript or TypeScript. So because we're using Go, there's no dependencies being detected or anything like that. So the question is, how do we build this dependency edge? How do we have this arrow in the graph? And this is what we're going to look at next. So first, and the easiest part, is you want to register your plugin with NX. So you can go ahead, open up your NX JSON, and then just enter your plugin there in the list. So this is the most complicated part. It's not too bad, so just follow along and don't fall asleep. So the first thing you want to do is call NX Graph or some other command. And because we register our plugin with NX, it's going to call our plugin and say, can you please process this graph for me? And now we're going to create a new builder using the project graph builder in NX. And we're going to use a trick. So because NX already knows about all the projects in the workspace, we're going to loop through every single project that's detected. And Go has this command called go list, where you can pass it a directory or a Go package, and it's going to list out all the metadata it knows about it. So now, once we have that, the part we care about is the list of dependencies that are detected by Go. So for each of the dependency, we're going to loop through, and then we're going to check whether this dependency is internal node or not. And what I mean by that is you can import either something that's within the workspace or internal, or you might be importing something external. So if it is internal, then we're going to call this method called add explicit dependency on the builder. So you'll notice here, I'm passing in the file that's being detected. And this will be more apparent why it's important in the next slide. But now that we're done, all we need to do is call get the updated project graph and return to NX. So now that we're done, NX will render. And let's see what that looks like. So because we have done the hard work here, you'll see this edge is now created. And as I noted previously, there's a file that we passed to NX to say why this dependency was created in the first place. And this is important when you're analyzing Workspace. You want to know why things are happening so you can debug. So this example was using Go. But what if you don't use Go? What if you use Python or Rust or something else? Or it might even be something like Vue, which is JS, but you might have like a Vue file. So we're going to go through similar steps, but this will be more generic, and you can apply to basically any language or any framework. So the first two steps are the same, but now we're going to take advantage of something else that NX provides for us, which is for every single project that's automatically detected. It also contains a list of project files that are within that directory. So for each of the file, and this is like left to you as an exercise, we're going to try and find all the imports within that file. So normally what you would do is pass your source file into some kind of AST parser, and then you can detect your imports that way. Then the check is going to be the same. Is this import internal or external? So once you have that, you call the add explicit dependency again from the builder. Then you're done. You return the updated project graph to NX, and NX will render it just as normal. So now your job is done. You can go grab a coffee or take a nap, whatever. And you'll notice we didn't touch anything else. We just extended NX. If you have caching, which you do, if you set up DTEs, your builds, everything still works. Your CI/CD pipeline works as before. And if you have NX Cloud enabled, which you should, it just continues to work as normal. You don't have to do anything special. So there's one last thing I want to cover. And this is if you do intend to publish your plugin to NPM to share it with the world, you want to generate or add a generator called preset. And this is a special generator, so when the user creates a workspace, they can pass in your package as a preset, and NX is going to check if this preset exists or not. If it does, then it will call it. So you can use this to, for example, set up a default project, like an app or lib. You can update configurations and anything else you need to do to make the workspace work for your framework or library. So that's it. Now you can go ahead and program in any language you want. And the last thing I want to say is, if you want some examples of how some people are doing this, go check out nx.dev/community. There's some plugins that are listed there. 3 I will call out. The first one is Go. So do not use what I show in this talk to create your own plugin. There's already one in the community. The second one is created by our own Gregory, and it's for .NET. So I think you're up to like 7,000 wiki downloads, roughly. So it's gaining traction, so definitely check it out if you use .NET. And lastly, if you're a Rust fan like John, who also works for Narwhal, check out his Rust plugin. And even if you don't use these languages, you might want to check out the source just to see how they're doing things. So that's it. If you have any questions, please find us after the talk sometime today, and we are happy to chat.
Thank you.
Thank you.